All right, what you may not have realized in our last topic with percents is that we were using something called the percent equation. And the way the percent equation works is that you take whatever the percent is and you multiply it times the whole number, and it gave you a part. And sometimes at the end we realized when we were doing like discounts, we had to then subtract the part from the whole to get our answer. Or we needed to subtract our percent from 100 and multiply by that percent that we were actually paying. Or if we found the tip or the tax, we might need to add it back on to our whole. So our questions have looked like this. Marcus got a 70% on a 30-question test. How many did he get right? So we knew how many there were in total, so the whole we can also think about as the total, and then 70% of that, so we would have said 0.7 times 30, and we would have gotten 21, so that meant we got 21 of the questions right. What we're going to be looking at is kind of like going backwards. So we are going to be given questions like this one. Marcus got a 70% on his test, and that meant he got 21 questions correct. How many questions were there on the test? And you could kind of fit in those words in total on there. So that means I don't know how many, but I got 21 right. So that means I found 70% of something that I don't know, and that equals 21. Well, remember, this is multiplication. To find the answer to my problem, I'm going to need to undo that by dividing by that same coefficient. So we find out that there were 30 questions on the test. So what makes this problem different? Well, in the first problem, we were trying to calculate the part. But in this one, we needed to find the whole. We can also think about that as the original or the total. So how do we go about solving a problem like this? Well, we figured out instead of multiplying, the second type of problem we might need to divide to find the answer. What I want you to do right now is I want you to pause your video here. I want you to take a look at these 3 questions and see if you can get the numbers in the correct spots and leave the correct blank open. All right, so let's take a look at the first one here. It says 40% of the students on the field trip love the museum. Oh, guess what? As soon as I see that percent sign, that is where it goes. That one's a no-brainer for me. If there are 20 students on the field trip, how many love the museum? Well, it tells me there's 20 students on the field trip. Well, that's telling me all the students on the field trip. So that would be my whole. So I would multiply those to find my part. The next one says 40% of the students on the field trip love the museum. Once again, 40%. If 20 students love the museum, how many were on the field trip? So if 20 love it, how many were there in total or altogether? So that means this is what I don't know, so I would have to divide to find my answer. This last one says 20 students on the field trip love the museum. If there are 40 students on the field trip, what percent love the museum? Well, right away, I don't know what my percent is. I know I have 40 students on the field trip and 20 of them love it. Some of these you could probably look at and solve, like 20 is what percent of 40? Or I could look at this and I can actually do the math. So for this first one, I would do 0.4 times 20, and that would get me, which would get me 8. So 8 students loved the museum out of the 20. For this next one, I don't know how many students went, but I know 20 of them loved the museum, and 20 is 40% of something. So 0.4 times something I don't know, so I'm just going to use a variable. I know that if I'm multiplying here, I have to divide to solve it, which means there must have been 50 students on the field trip. On this last one, I know that some percent times 40 equals 20. So some number times 40, remember we always put the variable second, even though it's first here in our order. When I divide by 40, you're going to get x equals 0.5. Well, that's a decimal. So we know to go from a decimal to a percent, we need to multiply times 100. So we end up with 50%. Down here at the bottom, there are some quick little helpful hints as to what you need to do. These right here, have those handy anytime we're doing work. Write them somewhere. Write them down at the top of your paper anytime you do something to help you remember these, because these are going to be super useful and helpful. If I'm trying to find the percent, I'm going to do the part divided by the whole, and then after I do that division, I need to multiply by 100 because I want to go from a decimal to a percent. So for instance, I get 15 problems out of the 20 correct. Well, anytime you take a test, if you put the number that you got right out of the number of total questions, and you do that division problem, the first thing that you get is a decimal. And in this case, I get the decimal set 0.75. Well, the last step is I need to multiply by 100, which gives me at 75%, and that's what it tells me is my answer or my score on my test. If I need to find the part, well, that's what we've been doing. So that's just that multiplication. I've got to turn the percent into a decimal and then multiply. So I answered 85% of the questions correct in my test. The test had 40 questions in total. How many questions did I answer correctly? So that means I just need to find 85% of 40. Well, if you remember, of means to multiply, and I turn the percent into a decimal. So if I want to know how many I got correct, if that was my score, that means I got 34 of the questions correct. This last one, if I'm finding the whole, how many I had originally or how many I had total before I started or what the price was before the sale, that is what I'm going to divide by a percent as a decimal. So if I scored 80% on a test, so 80% of, I answered 20 questions correct. How many questions were there on the test? Well, if I don't know how many there were on the test, 80% of, I don't know that answer. But I know that I got 20 of them correct. So same thing, when I turn that into a decimal, I'm multiplying it, and I'm like, oh, I don't know what it is. Stick a variable in there. I need to undo multiplication by doing the opposite. So I'm going to do the inverse operation, which is dividing by 0.8, which means that my answer is 25. So there were 25 questions on the test. My little teeny tiny handwriting. On the back, you're going to continue doing this. I'll do one more with you. So it says 960 students at a certain high school have a D or an F. This is 40% of the population of the school. How many students attend the school? Well, right away I see I already have the percent. So I'm going to say 40% of, which tells me to multiply. And it says how many students attend the school. So I don't know how many students attend the school. That would be the whole if 960 of them have a D or an F. Hopefully not all of them have a D or an F, right? So that means that 960 is my part. So what I'm missing is my whole. So when I come over here, I'm going to do 0.40 times something equals 960. And remember, I fill that in with a variable. I'm doing a one-step equation here. So if I'm multiplying by 0.4, I'm going to divide by 0.4. And I can write 0.4 or 4/10 as 40/100 as well. So when I do that division, I find out that there are 2,400 students at the school. That is my whole or my total. there are 2,400 students. And I can always check myself by doing 0.4 times 2,400 and seeing if I get 960. So I can always check myself by plugging my answer back in and seeing if it's a true statement. So what I want you to do for the next 1, 2, 3, 4, 5 questions is I want you to try those, and then I want you to plug them back in and make sure that they are correct. You'll be able to check your answer key, check your answers on the answer key with the substitute.